Hello everyone, welcome to this lecture. In this video, I would like to use GeoStudio SEEP-W software to solve this problem and find the discharge. So in this problem, we have a sheet pile that's been driven to the soil 10 feet. Our soil has coefficient of permeability equal to 1.64 times 10 to the negative 4. The water level in the left side is 15 feet above the soil, and in the right side is 5 feet above the soil. As you know, when you have a higher head, water is going to flow from the higher head to a lower head. So it's going to flow from the left side of the sheet pile to the right side. And we do have the impervious surface under the soil. So I'm going to open GeoStudio and start drawing my geometry. In order to draw the geometry, I only need to draw the soil, which is this region around the sheet pile all the way here. And then I define this water level here using boundary conditions for the left and right side, so upstream and downstream. As you can see, the total head in the upstream is 45, which is 30 plus 15. And the total head in the right side is 35, which is 30 plus 5. So I don't need to draw the water table because I'm defining the boundary conditions, but you can use some lines just to visualize the problem better. I'm going to define some points in these corners of the soil, which is one here, one here, one here, one here, 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 and here. So the point of this point, the coordinate is 0 and 0. This one is 0 and 30. This one is 90 and 30. This one is 90 and 20. This one is 90.5 and 20 because our sheet pile has 6 inches thickness. This one is 90.5 and 30. This one is 180.5 and 30. And this one is 180.5 and 0. Okay, so now if you think you might forget these points, you can write them down or put them in Excel. You can copy paste them in GeoStudio, or you can just answer them. So I'm going to share GeoStudio. Just a quick note, GeoStudio is not an open source, so you have to pay for it in order to use it. I do have the access to the full license through the university, so I need to make sure my VPN is connected, which is. You guys can use the student license, and that's free, but you have some limitations. You don't have access to all the options in the student license. But if you are using your laptop and you downloaded GeoStudio on your computer or laptop, then you have to use the student license. If you have Mac and you would like to use GeoStudio, you can connect to the a portal and use VPN to have access to the GeoStudio. And in that case, you're going to have access to the full license because that's the university license. So as you can see, GeoStudio, this is the latest version, 2021. You have this type of analysis, and the one that we are going to use today is the SEEP-W. So I'm going to click on that. You can also open a new project and then create a SEEP-W analysis on that. So here, there's a window opened up. This is a defined project window. So the name, I put SEEP-W analysis tutorial. And description, I'm just going to put the date. And that's 9/12/21. You can, for the description, you can write a note for yourself just in order to remember in future if you want to use this file, or if you want to give it to somebody else to work on it. So that's where you put the description. The analysis type is going to be steady state. As you can see, if I open that, you have two options, steady state or transient. If you're using the student license, you only have access to the steady state analysis. So I'm going to close this. And now, there we go. This is our screen. As you can see, if you go to, I'm going to save this before anything else. Let's save this. I'm going to put SEEP-W tutorial, save. Let's see what options we have here. We have some icons and we have some options here that you can just open them. So file, you know, it's like new, open, close, save, save as, edit, undo, redo, view. If you would like to view the units, you can click on it. This is like imperial units. You can view your grids. You can change the grid spacing. You can view, like you can change the zoom. You can see your toolbars. You can define a project. You can define a region. You can define lines. You can define points. You can define materials and boundary conditions. So these are the ones that we're going to use. We're going to use the define or draw region, lines, points, and materials and boundary conditions. Draw regions. We are going to draw a region for our soil. You can also draw points. If you draw a region, points will be automatically created, but to make it easier, we are going to define some points first. Sketch, you can sketch axis and you can sketch some lines in order to define some, for instance, if you have a water table or something, you can sketch them. A sketch and draw are different, so just pay attention to that. Modify, if you would want to modify anything, and also window, it shows you if you want to see the results window or definition view, or you want to see solve manager or any other options that you are interested in, and help button that you can use for help if you need, if you are confused about something. So I'm going to first thing sketch my axes. The first one, so the y-axis is the elevation, the x-axis is the distance. The unit for both is foot, so I'm just going to add that. You always add the unit to your axis label. If you remember from the geometry, I have x changing from 0 to 180.5, so I'm going to change my max to 200. And for the spacing, the increments, I'm not going to use the auto. I'm going to use 20 feet increments. It's up to you what you pick. It's not, doesn't need to be 20. For y, we had 0 to 45. I'm just going to pick 50. And for the increments, I'm going to use 10. And then I close this. If you want to see the whole defined project, you just go to this and that would fit to the window. As you can see, x is between 0 and 200, y is between 0 and 50. This is distance in foot and this is elevation in foot. Okay, so now I'm going to save this, and I recommend you guys to save as you go, especially if you're using VPN, because that might get disconnected or it might freeze, so you might lose your project. So I'm going to define some points. If you remember from the geometry, I gave you some coordinates for the points. I remember them, so I'm just going to add them. So the first one was 0 and 0, and these are the points around my soil region. So that's add. Then I had 0 and 30. Add. If you forget what these points are, you go back to the problem statement and you look at the geometry, write them down or type them in Excel. You can also copy paste them here. I remember them, so I just entered them here. So the other one was 90 and 30, 90 and 20, 90.5 and 20. That's under the sheet file. 90.5 and 30, 180.5 and 30, 180.5 and 0. And I can close this. So I have all the points. I'm going to save this and I'm going to draw a region for the swale. So I'm going to start from here. I'm going there. Then I get to this point. Then I go down. Then I go to this point. Then I go up. Then I go here, here, and here. And that's my region. If you have a hard time drawing this because the points are too close to each other, you can just zoom on this. And if you want to fit it to the window, then you would click on that, and that fits to the window. Awesome. So you don't need to draw the rest, but if you do want to, you can use the command sketch and sketch some lines. So I'm going to sketch a line for the upstream. So it was 0 and 45 and 90 and 45. That's upstream. For the downstream, I had 90.5, 35 actually, and 180.5 and 35. Okay, I can also draw my complete my sheet pile if I want to. I don't need to, but just make it a little bit easier to visualize what's happening here. 90 and 30, 90 and 45. Another line, 90.5, 30, 90.5, 45. Actually, I can do this because this is my sheet pile goes like 5 feet higher than the water level. So that's going to be 50. And then I see if I can modify this one. Let's just delete that and sketch another one. That's 90 and 30 to 90 and 50. Also, I can close the top part of that, which is 90 and 50, 90.5 and 50. And I can close this part as well. So it's going to be 180.5, 30, 30, 180.5, 35. Again, you don't need to draw these. Let me just check here. Right? Yes. You don't need to draw them. It's just for your own visualization purpose. So now, after I save this, I need to define materials. So define materials. Our material that you're using here, it's soil. It's saturated only. And the X is given, or Kx, 1.64 E negative 4. So when you have 1.64 times 10 to the negative 4, that's how you show it in an engineering format. And X and Ky are the same. We're assuming that's isotropic. So I'm going to close this. After you define it, then you can assign it. So I'm going to draw materials. So first you have to define it, then you have to assign it to your materials. So I'm going to assign it to this part. So now I have soil. Next step is the boundary conditions. Boundary conditions are the points that we know the information about them. So for instance, the upstream, we know the total head, and downstream, we know the total head. So I'm going to define the boundary conditions. Again, you have to define them and then you need to assign them. So we define them first. I'm going to use add new hydraulic boundary condition. Boundary conditions, you also show it by BC. boundary conditions. So I call it upstream. It is a water total head. It's 30 plus 15, so it's 45 feet. And because it's water, I'm going to use a blue color, maybe this one. And then I add one for the downstream. When you click on the add, you can create a new one or you can clone it, because I have the same type of boundary conditions. I'm going to clone it, and instead of upstream, I call it downstream. The total head for downstream is 30 plus 5, so it's 35. And for the color, I'm going to change a lighter blue. And then I'll close this. So I'm not done with the boundary conditions yet. I only defined them. So I'm going to draw them. Draw boundary conditions. So I'm going to pick upstream. Then I click on my upstream. Then I'm going to click on downstream. And then I'm going to click on my downstream. And now I defined and assigned my boundary conditions. The next step is creating some mesh. So GeoStudio is a finite element software. So how it works, it breaks the, it uses some, it defines some mesh, and then based on how fine those mesh are, that's your accuracy. So if you have finer mesh sizes, then you're going to have a more accurate analysis. So I'm going to define, I'm going to draw. I go to mesh properties. So draw mesh properties. Here you can pick what you want to be your element size. So these are our elements. So if you go really small, then your number of elements is going to increase and number of nodes is going to increase. In a student version, you only can have 5 or 8. So you can make this element size too small. So if I do this like 3, then you're going to have 685 nodes and 612 elements, which is more than the limit. So you won't be able to, I can do it in my full license, but you cannot do that in the student version. So if you're using the student version, you should be aware of that. So I'm going to change this to 3.5 feet to make sure I stay under that 508 elements. Okay, so I am going to close this. I'm going to save this. So I am done with modeling. The next step is to run the problem or run the software and get the results and then read the results. Okay, so I'm going to start the analysis by clicking on this start button in the Solve Manager window. Takes a few seconds. And there we go, we have the analysis. So here, you can see little arrows that shows the water flow. You can turn them off if you don't want to see them with this little button there. There are, I think I, here too. No, that's not that one. This is this one. Okay, I don't want to see them, so I just turned it off. If you want to see your equipotential lines, you go here and you click on the water total head and you see the contours. You are familiar with this. You have your equipotential lines. If you want to draw your flow lines, you go to draw flow path, and then you can draw your flow lines. If you don't want it, you just click on it and it goes away. Something like that. So you have your flow net. You have your flow lines, you have your equipotential lines. Now, let me save this. And then I would like to see two things, the discharge and the exit gradient. So if you want to see the discharge, in 2021 version, you go to draw, you go to graph, and minimize this. Then you add, let's say discharge. Discharge is a water flow versus the time. Then you click on this box, which gives you the sum of the values of y versus average of the x. And then you click on the set locations. So we are going to have a subdomain cross-section, and then you want to draw a line under the sheet pile from this impervious layer to the sheet pile. So I'm just going to click here, and I'm going all the way up, and then I click on show graph. As you can see, if I maximize this, then this point is the discharge value. If I click on it, you see here, next, like somewhere here on the window, you'll see the value of that point, which is 0.001083 cubic feet per second per unit length of your sheet pile. So, and this is not because we are using a steady state, so we are just only having one time. So that's the value of Q you see here, discharge. And also you can find it from here. Okay, so that's how you see the discharge in 2021 version. It's a little bit different in the older versions. You could draw a flux section, and then you could see the discharge on the flux section. But here in 2021, and that's how you do it. Okay, another thing that you might be interested in is the exit gradient. To see the exit gradient, you go to View, and you see the result information. Then it says, click or drag your rectangular to select any of these items: node, element, element node, full path, element, whatever you want to. So when we are looking at the exit gradient, we look at this area here. So if you, there's a window here. If you go down, you have water XY gradient, and that's your exit gradient, and that's 0.31. Okay, so that's about exit gradient. You may need to see your water pressure. If you want to see the water pressure, you go to Draw, you go to Graph, you add. This is a new graph. You're going to change this to water pressure. Let's show it by U. It's going to be the pool pressure, and that's the water pressure, versus the Y coordinate. And then you would say set locations. And then you can click at any point that you're interested in to find the U. Oops. And then you click on show graph. So if I want to, let's say, set location, if I want to draw a line here, I want to find the U or water pressure on this area. And I'm going to get this curve. In this curve, you see the water pressure here, and you see the coordinate Y on the x-axis. We usually show this the opposite way. We show the coordinate on the Y, and then we show the U or water pressure on the X. If you do want to edit this, you can right click on it, and you can export this data to Excel. So I'm going to name this pore pressure, and I'm going to save this. So it's going to also open in a new window. Okay, so I'm going to share this one. So as you can see now, you can plot this in a way that you want. So you go here, then Then you would select the data. I would have my X as a water pressure, and I would have Y coordinates on Y-axis, and then I would say okay, and then that would be the pore water pressure. So and then you can add the title, and then also you can add the axis title. So here you have pore pressure in PSF, and you have Y in foot. Okay, and that's how, if you want to save it, because this is CSV, if you want to change it to Excel, then you just change it to Excel and then save it under pore pressure name or whatever name you're interested in. Awesome. So that's the end of this tutorial. I hope you guys enjoyed it.